Okay, so on to question 11. Simply just asks, what are isotopes? This is an interesting question, but basically, isotopes of an atom would have the same number of protons. So what makes every element unique is that they have a specific, like they have their own number of protons. Like you wouldn't have an element that has the same number of protons as another element. And this is determined by an element's atomic number. So like for hydrogen, for example, there is only one proton, so its atomic number is 1. For helium, there's 2 protons, so its atomic number is 2, and so on and so forth. But in the case of isotopes, they would have the same number of protons, but what makes them different is that they have a different number of neutrons. So neutrons don't have a charge, unlike protons or electrons. Like protons have a plus charge and electrons have a minus charge. But in the case of neutrons, they are neutral. But they also have a significant weight to them. So in the case of like electrons, they're very light compared to protons and neutrons. And the mass of neutrons is pretty much almost the same as the mass of protons. So let's look at what our junior tutor said. It looks like they have a lot of helpful examples. So they said that isotopes are elements with the same number of protons but different number of, I think they meant neutrons. The number of protons indicate an element's atomic number, and adding the number of neutrons and protons result to the mass number. In other words, isotopes are also elements with the same atomic number but different mass number. That's another way of putting it as well. Hydrogen is an example of isotope, as seen in the figure below. They all have the same number of protons but different number of neutrons. So here is a protium. So there is no neutron in protium. There is only the 1 electron and the 1 proton. In deuterium, there is 1 neutron shown, the 1 electron and the 1 proton, and you can see that it is heavier than your protium. For tritium, you'll see that there are 2 neutrons, 1 proton and 1 electron, so it's even heavier than deuterium. But these are all different isotopes of hydrogen. So basically the atomic mass that you would find on the periodic table is an average of all of the masses of these isotopes. So that's why some of them are like have decimals. It's because it's an average of all the different isotope masses. Okay, so this solution was correct, but I'm also going to copy this part and just correct that part. Different number of neutrons. But like literally everything else was correct. But that is a pretty main difference in the solution. I'll just say that this was incorrect for now.